Hello, this lecture introduces a microcontroller from Microchip company. We will describe the characteristics and ports of PIC16F877. The term PIC stands for Peripheral Interface Controllers and is currently expanded as Programmable Intelligent Computer. Our focus in this lecture will be on the PIC16F877. PIC16 is a family of microcontrollers made by Microchip technology. PIC16F877 is one of the most advanced microcontrollers from Microchip. It is an 8-bit microcontroller. It has wide range of applications because of its low price. It's very cheap. It has high quality and easy of availability. PIC microchips are designed with Harvard architecture and are offered in various device families. This PIC16F877 belongs to the mid-range family. It has high operating speed and it uses 14 bits for instructions. This is the figure for PIC16F877 chip. It has a total number of 40 pins and there are 33 pins for input and outputs. This PIC has high performance RISC CPU. It has a reduced instruction set computer design. So the central processing unit on the existing architecture supports only a smaller 35 instruction set. This PIC executes the instructions one at a time in a sequential order as stored in program memory. Each instruction needs one machine cycle except the jumping instructions. The jumping instructions need 2 machine cycles. And note that one machine cycle is equal to 4 clock cycles. So the instructions are usually programmed into the flash memory of the processor and automatically executed by the microcontroller on startup. In general, the architecture of the 8-bit PIC microcontrollers can be categorized as mid-range family that uses 14-bit instruction word. It offers a 14-bit instruction set. We have the baseline family, which uses 12-bit instruction words, and we have high-end range family, which uses 16-bit words. So the PIC16F877 belongs to the mid-range family and it uses 14-bit words. We will limit ourselves to the mid-range family, knowing that if you have it all figured out, you will move very easily to another family and even to another microcontroller. Here we can see the basic features of the PIC16F877. 16 indicates that this microcontroller belongs to the mid-range family, which uses instruction words of 14 bits. The F indicates that the PIC microcontroller uses flash memory and can be erased electronically. This is one of the main advantages of the PIC. It can be write erase as many times as possible because it uses flash memory technology. So this F indicates that the PIC uses flash memory technology. The operating voltage is between 4.2 2 and 5.5 volts. If you provide the PIC a voltage more than 5.5 volts, it may get damaged. This PIC operates up to 20 megahertz frequency. 877 here is the reference for the PIC. It's the name of the PIC. Let's have a look about other features of this PIC. The PIC16F provides 8 kilobytes of flash memory, 368 bytes of RAM, 256 bytes of EEPROM, 5 input-output ports, 3 timers, and 10-bit up to 8-channel analog to digital converter. Here you can see the basic internal architecture and memory organization of the PIC16F877. This PIC is an integrated chip, consists of a CPU, timers, input-output ports, and 3 types of memories. We will talk about these types of memories in a later lecture. So the PIC microcontroller CPU consists of the ALU, the arithmetic logic unit. It's mainly used for arithmetic operations and to take logical decisions. The data memory of PIC16F877 is separated into multiple blocks called banks. According to the type of the microcontroller, these banks may vary. The PIC16F877 only has 4 banks, bank 0, bank 1, bank 2, and bank 3. Each bank holds 128 bytes of addressable memory. We will see the pin configuration of the PIC16F77 in this slide. As it has been mentioned before, there are 40 pins in this microcontroller chip. We start with pin number 11 and 32. So pin 11 and pin 32, they represent the VDD. These 2 pins are the positive supply for the input, output, and logic pins. Both of them should be connected to 5 volt. Pin 12 and the pin 31 represent the ground reference. They should be connected to 0 potential. So pin 12 and pin 31 are the VSS. They represent the ground reference for the PIC. The PIC consists of 5 ports, port A, port B, port C, port D, and port E. All pins of these ports have multiple functionalities, but we can use one function of each port at a time, or we have to program it smartly so that we can switch between different functionalities. For example, like port C. So like here in port C, the pins can be used as digital input pins, also as digital output pins. Also, they can be used for UART communication and I2C communication. So they can be used for multiple functionalities. Port A consists of 6 pins from RA0 to RA5, from pin 2 to pin 7. All of these are bidirectional input-output pins, so they can be used as input or as output pins. Pin 2 can also be used as an analog pin. A and 0 means analog, so we can use this pin as an analog pin. It's built in analog to digital converter. Pin 3 RA1, AN1. This can be the analog input 1. Pin 4, it can also act as the analog input 2. Also, it can be the negative analog reference voltage. So negative analog reference voltage can be given to it, to this pin, pin number 4. Pin 5, it can also act as the analog input 3 or can act as the analog positive reference voltage. RA5 can be the analog input 4. Also, there is synchronous serial port in the controller, and this pin can be used as the slave select for that port. Pin 6 can act as a clock input pin. So each of these pins have multiple functions. We can use one function, or we can use all the functions in a smart program. Pin 33 to pin 40, all these pins belong to port B. RB0, here, pin 33, can be used as the external interrupt pin, and RB6 and RB7 can be used as in-circuit debugger pins. So port B also includes 8 pins from RB0 to RB7. Port C consists of 8 pins also, which are pin 15, 16, 17, 18, 23, 24, 25, and 26. Port C, it's also a bidirectional input-output port. Port D includes 8 pins, and port E includes 3 pins. We will provide more description about these pins in a later lecture. Also, we have the first pin, pin number 1. This is pin number 1. This is pin number 1. This represents the master clear pin of this IC, of this PIC. It resets the microcontroller and is active low, meaning that it should constantly be given a voltage of 5 volt. And if 0 volt are given, then the controller is reset. So when we say reset a microcontroller, this will bring it back to the first line of the program that has been burned into the PIC. So here we have a push button. We have a push button here. We have also a resistor connected to the pin. The pin is already being supplied by constant 5 volt. When we want to reset the IC, we have just to push the button, which will bring the master clear pin to 0 potential, thereby resetting the controller. Another circuit is needed for the microcontroller. This PIC doesn't have an internal oscillator, and so it needs an external one. A crystal resonator could be connected between pin 13 and pin 14 to provide external clock to the microcontroller. So the PIC needs a clocking source to drive its system timing, and this is often done with a crystal like this. So pin 13, this is the oscillator input or the external clock input pin. Pin 14, this is the oscillator output pin. So here the clock circuit is very important to the PIC. The PIC will not work without an oscillator. Also, the reset circuit is very important to reset the microcontroller when needed. In next lecture, we will talk about data memory and program memory in details. Thank you for listening.